I wanted to just consider the context in which we look at carbon for the built environment and within the construction industry. Most of you are familiar with sort of the whole life cycle of the buildings. And the couple of things I wanted to sort of highlight on this is that there is quite an interesting balance between embodied carbon and operational carbon. The two have quite similar impacts in the current market, in the current context for a lot of developments. And it's something that when we're looking at analysis, it's critically important to make sure we're looking at the whole big picture. And we always try and work with our clients to understand where their opportunities are throughout the building's life cycle. What we found on a number of projects recently, particularly in markets where there's a very high level of renewable contribution in the grid, or markets where there's newly implemented net zero strategies, for example here in the Middle East, is that once you start to look out over the life cycle of the building, going 20, 30 years down the line, your operational impacts start to reduce quite significantly because of the decarbonisation of the grid. And so actually it really puts the onus then on the importance of embodied carbon up front, and actually looking at that and measuring that and finding ways to reduce it. But also thinking about the embodied carbon that occurs during points through the life cycle. So actually when you're looking at maintenance and repair, refurbishments, when you're looking at end of life, in particular, what do we do about deconstruction and recycling and reuse? And thinking now about how we as designers can refine what we're doing with the buildings, looking at sort of modularization, prefabrication and deconstruction, trying to really cut down on that upfront resource use that we're committing to and putting into the buildings that's going to be there for the whole life, that can't be changed. One other aspect to think about as well, and sort of building a little bit on that, is about the perceptions we have around life cycle. When we're working on a lot of projects, we find clients are very focused on what's immediately in front of them. I want to get my building built, I want to get it occupied, I want my tenants, my visitors, my guests, my residents moved in, because that's when I start getting my revenue stream. But the challenge with that is that we're focusing very much on the here and now, and we're not looking long term. And it's very much a human nature kind of thing. We tend to look at what's immediately in front of us and find it difficult to forecast into the future. But when you're considering life cycle and you're considering carbon assessment, we really need to get the whole perspective and make sure that we're looking all the way down the building's life, looking beyond the usage that we know it's going to have now and looking at the potential for adaptability. Part of the challenge with this is a real lack of data. It's really challenging to try and make these assessments. Early on, we don't have consistency around the approach we take to measure products, to measure their impacts when they're being manufactured and when they're working to site. During operation, there's different methodologies to consider what happens in terms of refurbishment, and there's very little, if anything, at the moment around the end of life stages. And so for us as consultants, it's really critical to understand what the data is that we've got and how we're using it, and to make sure that our clients are informed about that and about the limitations of the analysis, so that they can make the most relevant decisions based on the data that's in front of them. And I think in particular it's something that we as an industry in the region need to really focus on and look at how do the decisions we make as part of the design process impact on the overall carbon footprint for the building as a whole. So thinking about the application of this on some recent projects, this is a case study I want to share. I can't say too much about the project as it's a confidential one, but what I can say is it's here in the UAE. It's a cultural building. It's a very complex facade design. There's real interest on the sort of the form and the aesthetic and the integration with the surrounding buildings. So in terms of carbon footprint, it's much bigger than similar buildings of its type, and it's a challenge to sort of benchmark with data in the region. And so we've been looking globally at other benchmarks in Europe, in North America for similar building types, and particularly the sort of higher end, more unusual facade intensive construction projects, and still found that the building was quite significant in terms of its carbon footprint. And the main reason is the level of detail within the facade and the scale of the facade relative to the occupied area of the building. And as you can see from the pie chart here, there's a huge amount of carbon intensity in the concrete and within the metal within the building, the structural steel. And so this for us was a real challenge area or an opportunity area to sort of work with the client and the design team to think about how we could refine it. We actually, with a lot of early stage assessments, it tends to be a little bit estimation in the dark, guidance, benchmarks, kind of ballpark figures. What we wanted to do for this project was actually a more attuned and specific study. So working really closely with the structural engineer, we actually went through the breakdown of where steel and concrete were being used in the building to understand what were the critical structural criteria and where we had the opportunity to refine things and to fine-tune things. And working with them, we managed to identify areas where we could make up to 90% replacement for the steel with post-consumer recycled content, and between 30 and 60% replacement of cement in the concrete, based on what the structural need was or whether it was decorative. And so this allowed us to make almost 60% reduction overall in the carbon footprint for the superstructure and the substructure of the building, which is a huge saving, and something that really came about through the kind of collaborative engagement with the team on the project and a very close working from ourselves with the structural engineers. And just highlights the importance of understanding what is driving the way the building's being designed and where can we make refinements and work together as a team to try and optimize that. Another project that we've worked on quite recently, as I mentioned, we found there was similar impacts in terms of sort of the benefits you can get from replacing materials and enhancing the facade performance. But as a flip side to that, one of the things we discovered was that when you look at the enhancement that we quite often make in design to try and reduce operational carbon, so looking at where we're upgrading the facade, enhancing insulation and things like that, we were finding that project where we had a forecast in the carbon intensity in the grid that was going to change over the lifetime of the project, it was actually mitigating a lot of these savings because we're putting so much in up front. And so that fed into the same sort of analysis early on to say, well, actually, is this the right kind of decision to be taking, and how is this going to change over the life cycle? To close out, I just thought I'd share kind of what we have found from recent projects to be kind of the key success factors in terms of when you implement carbon calculations, how you really actually drive an impact. And for us, that effective implementation has to really have impact. We're not just doing an assessment because we want to tick a box or get credits for a rating system. It's about actually making a change to the design and understanding the best way that change can happen. The first of these is that any sort of assessment like this has to support decision making. We need to have data that's attuned to the stage of the project that's going to help the client decide on key project critical decisions, whether it's the scale of the building, the area, the style and the materiality, making sure that we're giving them guidance at concept stage that's sort of attuned to the kind of decisions, detailed, that's getting more refined, but actually enabling them to really think about what's the cost implication of this, what's the life cycle impact of this, relevant to sort of the level of detail I have in other areas. Thinking about the accuracy and the reliability of that data as well. Obviously it's a big challenge here in the region given the limited data availability, but quite often what we're doing on projects is comparative studies. So actually saying relatively option A is better than option B, or taking this approach, or putting in this level of modularization. So having that kind of perspective is really valuable, but also making sure your client understands that, to say, well, actually, look, there are data limitations. We think strategy A is better than B. The figures we've got are comparable, but they're not absolute. So if we want to start talking about net zero carbon for the life cycle, that becomes a different question and a different conversation, and we need to then refine some of the assumptions. And so making sure that the accuracy and the suitability of the data is there. And finally, making sure that the outcomes, the recommendations, whatever we're deciding to do, is communicated in a tangible manner. If you're not giving the client information that they can understand, then we're not really doing our job. And so that sort of user experience, that engagement with the client project to project, development to development, is really key.